So today's lesson is another continuation of quadratics. Okay, so today we do the lesson of what? Different, come on, focus. Different forms or shapes of quadratic. Different form of shape or shapes of quadratic. They never call them shapes. They call them what? They always call them forms. So quadratics can come in how many? Three. Only three. There's absolutely no more than three ways that you can actually look at something and say it's a quadratic for sure. Okay? And today we'll learn how each form looks like. So three different forms. Okay? Three different forms. Okay? Well, one question could be, why do we need three different forms? Why can't we just live with one form and always use it, always have it? Because every single form, has its own, I like to call it superpower. Every single form is good for something. Okay? So knowing how to identify and work with each form is important because of two reasons. Number one, each form can tell us something about the quadratic immediately just by looking at it. In other words, you can know certain information about the parabola. What does parabola mean? Parabola is the shape or the graph of a what? Of a quadratic is the math form. Parabola is the shape you sketch. Always like that. About the parabola just by looking at a certain form. The second reason, each form can be used in a certain way to easily answer certain questions when the math is concerned. Certain questions about the quadratic can be answered easily by using a certain form. So we're going to talk about each form, give you the form name, give you what it generally looks like, and give you what some examples. So let's do the first one. So the first one is called what? Come on. The first form is called what? Standard form. Okay, it's called the standard form because any polynomial can always be put in something called standard form. What is the form of a standard form? Here you go. So the standard form looks like this: a x squared. Actually, sorry, before you put the a, put plus minus. Positive minus a x squared, positive minus b x, positive minus. Can anyone take a guess for the third one? We've used the a, we've used the b. C. Thank you. Okay. What are the possibilities of the a, the b, and c? What are the possibilities for the a, the b, and the c? Okay. So here's what we're going to say about each one of them. Okay. So let's do the first one. So a can be any value, any value, nicely, any value except for one number. A can be any number in the universe except for one. It cannot be what? It cannot be zero. Yes, go ahead. See, I'm putting plus minus to indicate to you that A or B or C can be what? Can be plus or minus, and also any value that, as long as it's not what? Not zero for the A only. Okay, that's what I'm saying. Yeah, so I always like to use plus minus just to give you the what? The implication that A or B or C could be what? Legit any number. However, A has what? Has an extra condition. It can be any value except for what? Okay, go ahead. So except zero. You cannot put zero at the beginning. I'm going to show you why. Except zero. Okay. What about B? B can be as well any value. I'm going to squeeze this a little bit. Mhm. Can be any value. But this time, it can be what? It can be, yes, B can be zero, even zero. How about C? C is the same as B. It could be absolutely anything, including zero. So, oops. C can be any value, even 0. Okay. All right, everyone, let's write some examples. Who would like to give me examples for A, B, and C, taking in account any of these conditions? And I'll let you know if you're right or wrong. Go ahead. Who would like to propose one? Come on, wake up. Hamza. Yeah, you can give me just for A, or if you like to do the whole thing, A, B, C. The only thing I'm going to ask you to do is what? Pick any numbers that you like, as long as they satisfy what? These three conditions. Go ahead. What do you want A to be? Sure. So -5. And you have to put what after it? X squared. Remember, the feature of any quadratic is it has to have a power of what? 2. Thank you. Well, the highest power has to be 2. Nothing else is allowed to be higher. Okay? You want to put 0? Go ahead. What do you want your C to be? Sure. Can I write like this? Can I write 24x or just 24? Exactly, because C is the only number or the only one that is a number by itself. Okay. How can I check that this indeed is a quadratic? What website do I always go to? Desmos. Exactly. Thank you. So everyone, let's go and sketch it. Okay. Easier to type here. So Hamza, what was it? -5 x to the power of 2. Where is power? Keep going. Technically, you wrote what? Everyone, we wrote what? Plus what? Oops, here. Plus, plus 0 times anything is what? 0. So does it stay or go away? So you can choose to show that 0 or to do this. Look, you can completely skip it. It's up to you. I'm going to show you that both ways work. But I'm going to bring it back just to emphasize that you chose a value for the b. So go ahead, and here it is. Plus 0x plus what? Is this a quadratic? Does it look like a parabola? Do I really care that it's so thin? Did we care about the width or the thinness of the parabola? No. It goes up, reaches a what? Is this a maximum or a minimum? Maximum, and then what? Comes down. Okay, what did I say about this 0x? I can show it or what? Not show it. Okay, let's take it out. And I am basically claiming that even if I don't show it, nothing should change with this. Okay. So instead of removing it, I'm going to write the same thing, but hide the what? Hide the 0x. Okay. And I guarantee you the new one will just perfectly what? Imprint on that. All right. Here it is. -5x squared. Ready? Plus, just what? Just plus 24 because I'm skipping the 0x. 24. There we go. Exactly the same. Exactly the same. So you can choose to what? To show the 0, 1 or not show it. Completely up to you. Okay, so I'm going to write here equals, equals -5x squared plus what? Just what? Okay, here's one example. Someone give me another example. Hamad. Pick again. He picked -0 and 24. Pick anything else you want. Again. So that's example number 1. Example number 2. 7. Sure. Plus 1x. Sure. Plus 10. Not 0. Some number. Some number. Perfect. So Go here. 7x squared. What was it again? Plus what? 10x plus, I think 1. Oh, my bad. Is this a parabola? That green thing. Does it look like a parabola? Yes, it's open up. That's it. It's basically this. Look. I can't bend it anymore, otherwise it would break. Okay, but it kind of follows the same shape. Okay, so 7x squared plus 10x plus 1. Oh, doesn't matter? No, okay. So I showed you one. I wrote another one. Both of them will be what? Parabolas. But are they going to be the same shape? Do you think if this is 1 and this is 10 and then I replace them, would they stay the same shape? Absolutely not. Look, if I make it 1 and 10, it will be a parabola, but there's no way it's going to be the same shape. Look, if I make this 1, I make this 10, changed what? It changed, at least it changed its location. So always know that when you change the numbers, it's still a parabola, but a whole different one. Okay? Okay, I want 2 more examples. Come on, use other numbers. You're just using negatives and positives. Use something else. Come on, study. Remember, any numbers are okay as long as the A is not what? That's the only thing. Everything else is fair game, open season. Okay, negative 10, negative 10x squared, you mean? Okay, plus 11, plus 11 or 11x? 11x, 20. But you're still using what? Negative and positive whole numbers. I want you to expand your thinking about numbers. Hamza, go. Ah, nice. So you're using what? What kind of a number? Sure. So what do you want? Negative 0.75 x squared. What do you want for b? Can you mix decimals and fractions? I did not tell you what? I did not tell you any restrictions on the numbers, except that the first one cannot be what? Anything else is open, open season. So what do you want to give me a fraction that you want to use for the second number? 5 over? Sure. So plus everyone, plus 5 over 8 x's. What do you want to use for the last number? Say again? Positive or negative? Plus 1.25. All right. Okay, write it down so someone can remember to tell me what it is when I do it on Desmos. Okay. Hamza, what was it? Mm-hmm. Mm-hmm. Babala? Absolutely. Okay. All right. What did we say the A cannot be? So let's make one of them, any one of them. Let's take this one, for example, and make this minus 5, make it what? See what we get. Minus 5x squared. What was it? Plus 0x plus 24. What did they say I'm going to make? I'm going to make this guy what? Okay. Can someone guess what's going to happen before we do it? Can someone guess what will happen to that curve if I bring that minus 5 to a perfect 0? Say again? What's your reason that it will become just a line? Why would you have that sense? So you're saying if I put this as 0, it completely what? Goes away. And this goes away. So I only have just what? All right. Let's see. Yeah, that's a what? Not just any line. A perfect what? Tilted or horizontal line? Horizontal line. So is this a curve anymore? Nope. So what does that mean? Your first number cannot be what? Any other number can be 0. Like if you put this back to -5 and you make this 0 and you make this also 0, guess what? You still have a what? You still have a what? What shape is this? So which one is the most important number? The third one, the second one, or the first one? The first one has to be anything but 0. All the other ones you pick. Completely up to you. Okay? Let's do another one. For example, here's one. This I don't know, 3x squared, sorry, plus 7x plus 5. Is this? Oh, you don't see it. Is this a parabola? Yes, it is. What am I gonna do now? I'm gonna make this 3 a what? 0. What do I get now? A perfect straight line. By the way, does anyone know why it's a perfect straight line? Because what does this look like if I remove this completely? You remember what form this is from grade 9 or grade 10? What's the equation of any straight line? Y equals mx plus b. There we go. Mx plus b. So it's what? It matches the form. That's why your first number cannot be what? Cannot be 0. Because then you go from a curve to a what? To a straight line. And we're not studying straight line in this unit. We're studying what? Starts with, well, what starts with Q? Quadratics. Exact. Quadratics are completely different from line. Okay? So that's it. That's the reason why it cannot be. So I want you to write this one: 0x squared plus 3x plus 5, and under it say wrong line. Wrong line. Okay. So I think now we're what? We're good with the first form, which is called what form? Standard form. Okay. By the way, the reason they call standard is because basically what you write everything, out in the open. No brackets, nothing. You lay out everything as you see it. Some number x squared, some number x, some number by itself, and that's it. That's why they call it what? Standard. Okay. Now let's go to the what? To the next one. What's the next one called? Vertex. Did we cover the word vertex before? Can someone tell me what was the meaning of the vertex? Or what was the vertex of a parabola? What's so special about it? Where is it? Any way you can say. Say again? Interesting. So the vertex what? It well, it doesn't cut it. Remember, the axis of symmetry is the one that cuts, right? But where is the vertex? Right in the middle of the what? Right in the middle of the parabola. Give me another feature of the vertex. It's either where or where. It's either the highest one at the very top or the lowest one at the very bottom. Okay? The vertex form is very powerful because just by looking at it, you can know where the what? You can know where the vertex is without sketching, without doing any numbers, nothing. You just look and write it. It's worth 1 mark. Done. Okay? So how does the vertex form look like? Everyone, here's how it looks like. How did the first one start with? How did the standard form start with? But what was the very first thing we wrote? Plus minus. Same thing, everyone. Plus minus. And then what did we write? A. Okay, what did we write in the standard form after A? X squared. Here, we're going to start what? We're going to start writing different things. We're actually going to use what now? We're going to use bracket, okay? But the inside of the bracket is going to be interesting, and I'm going to show you on Desmos why it's interesting. So here's the bracket, okay? What's going to be inside the bracket? Well, before I tell you what's going to be inside the bracket, I'm going to tell you what's going to be outside of it. Outside of it on top is going to be the power of what? Which is the standard what? Or the most important power in a quadratic. What's going to be inside? Here's what's going to be inside. X, okay? Now, instead of A, B, and C, and again, don't ask me why. These are just the rules for the symbols they use. In the standard one, they used what? A, B, and C. In the vertex one, they use A. Again, I'm showing you what you guys see in future math courses. They use A, and then what? Again, not me. H and what? K. And then what do you put behind each one? Either a plus or K. Can someone guess what the rules are here for A, H, and K? What was the rule for A in the first one? Anything but? Great. Guess what? Good news. It's the same exact rule. Come on. So A can be any value, please, except for what? Yep. What was the conditions for B and C? Including 0? Guess what? Good news. H and K are like what? B and C. They could be what? Any numbers, including. So instead of writing it as two different conditions, we're just going to write it as what? One condition because they are the same. So we're going to say what? H, and K. There's no need to put them in quotation marks. I'm just going to put them in quotation marks. You don't have to. H and K can be any values, including 0. Okay, I'll take examples. Go with purple. Who would like to give me the first example? Sadia, if you don't mind. Give me any first example you want to do or you want to, say, to suggest, as long as it what? Two things. Exactly matches that form in purple and matches those two conditions in red. Any numbers you want, as long as they satisfy the two rules. Sure. -7. You have to write it exactly the way it's written in the purple. So what do I have to put after the -7? A bracket, and then goes what? X. And now you choose. Any number can go where the H is. And you can choose either a what? Or go. Anything you want. Positive, all right? Positive what? 5, sure. And then what do? You what? Close the bracket. And on top of it, you have to put what? 2. Last number. Again. Plus 20. 34, 5, 4. All right, everyone, let's check. Minus, where is it? Okay. -7. Then you open what? Bracket. And then Sadia said X what? Positive what? 5. Ahmed, what do I do now? Close the bracket. Put what on top? You have to put a square. And then you put the very last single number, which is? Is this a quadratic? Okay, everyone, pencils down. Check out what did we call that form? We did not call it standard. We called it what? What did we call it? We called vertex. Everyone, check this out. This is not a coincidence. This is the power of the vertex form. Can someone read those two numbers? The ones on the dot. -5 and -5 and 24. Do you see them in the equation? Do you see 24 in the equation? Where is it? Is it the first number, second number, or last number? This number is always going to be this number. 24/7, all the time. What is this number? Is it 5 or -5? It's -5. What is this number? No, this one. Are they the same number? Okay, are they almost the same number? What's the only difference between them? If this one is positive, this one is what? Here's a question for you. What if I, instead of Sadia saying +5, she said -5. What do you think this one would be? Well, let's see. Everyone look. Check this out. Where did it go? On the other side. Let's check the values. By the way, did this one change? This one. Why? Because did I even touch this one? But did this one change? It became what? Because now here it's what? That's why we call this the what? The vertex form, because you can just look at it and at least tell me where the what? Where the vertex is. One question. What number here does not appear here at all? Like it's completely irrelevant and unimportant. Exactly. So the A has no what? Has no significance or importance in which form? The vertex form. I just need this guy and this guy, and I'm done. Here's a question for you. Is this open up or open down? Come on. Is it open up or open down? It's open down. My question is, I just told you that the A has no what? The A is not what? The A is not important. I lied. Is this open up or open down? What's your very first number, the A? Positive or negative? What do you think is going to happen if I make this minus a positive? Okay, so question. How many people say if I make that a minus 7, if I make it a positive 7, this will flip up? Raise your hand if you think so. Good. Second question. Do you think the location of that point would change? So do you think the vertex would change location from 524 to something else? How many people say no? It will only flip up and it will not change location. Okay, Sophia, why? Because what's the only number I changed? The -7 to a 7. Did I even touch this number? Did I even touch this number? So that means what? My vertex should not be touched. Only my what? My opening. It goes from down to. All right, let's see. Ready? All I'm going to do is just erase this -7. 3, 2, 1. Boom. Same point. Let's check. If it doesn't, I don't have a job. Never fails. You see how easy the vertex form is? It's so powerful. It tells you two things: where the vertex is, and if it's what? Open up or. Isn't that usually more than enough to at least know the general shape of the quadratic? Yeah. I mean, you might not know the exact point it hits, but at least you know what? If it's what? Open up and open down, and where is it in your space, right? Is it here? Is it there? Is it there? Is it there? You can know that within 10 seconds. Yes. Sure, go ahead. Okay, so I want someone to give me what? Another example. Hamza, go. Sadia, give us the first one. And I want you to go, if you want, crazy with any numbers you want. Go ahead. Sure. Remember, as long as they satisfy the two conditions in red, I'm happy. You get full marks. Nice. You're going with decimals again, all right? Uh-huh. You're using the same numbers again, right? All right. Uh-huh. All right. Can someone tell me if this is going to be open up or open down? And what is the only number that you need to care about to say that? Is your first number positive or negative? Done. It's open down. Okay. Who would like to tell me the location of the vertex? The location of the vertex point, or the two numbers that will make it to the vertex point. Raise your hand. You already told me that the -1.25 only tells you if it's what? Open up or open down. And in this case, it's negative, so it's open down. Who would like to tell me what the two numbers will be for the vertex? Sure. So you're saying, say again? Okay, that's the first number. What's the second number? Okay, all right. Let's sketch it. Okay, what's my first number? -1.25. What was this one? Positive what? 5/8. And what was this one? 0.25. Okay, it's right here. I'm gonna zoom in because it seems to be right here. So Sadia, you said what? You said that your vertex is gonna be at what? At 5.8 on the x and 0.25 on the y, right? Okay. Did Sadia get it right at least for the second number? Did Sadia? Yes, she got it right. She said that the second number is gonna be this guy, and it is this guy. Did she get it right for the first number? Are you saying that because it shows as a decimal, or are you saying that because of some other reason? What's the, well, okay, Muhammad? What's the other reason that you're saying that Sadia almost got it right, but not quite? Exactly. What's my number here? Oh, sorry. What's my sign here? Positive. What's my sign here? Negative. So remember, Sadia, remember, it's always like that. This number does not flip. This number stays the same. If this is positive, this is positive. If this is negative, this is negative. But this one is always going to do what with the sign? Flip it. Question for you. Is this number the same as this guy? Yes. Decimals does not show what? Fractions. It shows what? Decimals. Well, let's check. Is 5/8 indeed 0.625? You can check on your cell phones right now. I'll check right here. 5 divided by what? 8. Yep, it is 0.625. So now we understand why it's called the what? The vertex form. Because you can just look and know the vertex right there. I have a question to everyone. What's this power? What if I make my power vanish? What do you think this shape will turn into? Again, remember, when we made the 0 on the first one, when we made the 8, 0, when we made the A 0, what did my curve turn into? It stopped being a parabola or a curve. It became a what? A straight line. Do you think it's going to have the same effect here if I take out the 2? I don't know. Let's see. Everyone, all I'm going to do is, I'm not even going to make the 2 a 1. I'm going to completely remove it. Check this out. 3, 2, 1. What just happened? So what does that mean? What's on top of the bracket every single time, if you want to generate a parabola, has to be a power of what? Has to be a power of 2. Otherwise, you make a what? What if your power is -2? Do you think you're ever going to make a parabola? What did we say that the most important power is in quadratics? You cannot have any negative powers. You cannot have any fraction powers. You cannot have any decimal powers. Well, let's see. I'm going to make it 2 again. Look. Then I'm going to make it what? A -2. Everyone, check this out. It's going to look super weird. I'm going to even zoom out to show you as much space as possible. Here it is. 3, 2, 1. Is this a parabola? I don't care what it is. Is this a parabola? No, no parabola ever looks like that with what? With an infinite hole in the middle. So that's not what? Not a parabola. Okay, let's bring it back to 2. What do you think is going to happen if I make my power what? No, 3. Again, 3 is higher than what? We said that the maximum power that you need to see in a quadratic is what? Is 2. Let's make 3. I don't know what it's going to look like. I know it's just not going to look like that. Whoa. By the way, is this a parabola? Oh, that's 34. My bad. Come on, is this a parabola? No way. I don't care if it goes. No, it has to perfectly go. Sorry, go up and go down, or go down and go up. It doesn't go in a weird like saddle shape like this, like what you put on a horse. No way. Okay. So your power on top of the bracket must always be what? 2, and that's it. Okay. So I'm bringing it back to 2. Question: what if I make this a 0? What? It's definitely gonna turn into another what? Another line. Look, everyone. I'm not gonna delete the whole thing. I'm just gonna make this one 0. 3, 2, 1. What did I get? An infinite straight line, horizontal, parallel to the ground, or parallel to the x-axis. So again, your A cannot be what? Can this guy be 0? Can this guy be 0? Great. Let's check. What was it? Minus 1.25. Okay, everyone, look. I'm gonna make this one 0. This one, the second one, the 5/8. Is this still a parabola? I'll make even the other one 0. Is this still a parabola? Yes. So what does that mean? You can make any number 0 except for the what? For the A or the very first one right before the bracket. Done. So let's change it and say, so what would be a wrong one? Making this what? 0. So I'm just gonna propose a new one. 0 x minus 7.3, let's say 7.3 squared plus 2.2 over 9. Wrong, because that's gonna be another what? Another what? Another line. Every time you make the A 0, it's a line right there. Done. Don't think about it. Nice. How many forms have we covered so far? 2. What are they? The first one was what? Standard. You just lay them out power by power. And the second one is called what? And the vertex always has a what in it? A bracket with a power on top of the bracket. Okay. Sadia, what's the name of the last form? Say again. Factored. Comes from the word what? Factoring. Everyone, factored probably is going to be the most important one for the rest of this unit and for so much stuff if you take grade 12 college with Mr. Fonseca, term 1, term 2, or next year or whatever, okay? So make sure you pay special attention to the factored one. I mean, they're all important and powerful, but the factored one just seems to be the most used one in general. Okay, so let's zoom out. Okay, factored. Question, everyone, before we start. Study. How many people remember? I'm not going to ask you a factoring question, but how many people remember seeing factoring before or being asked a factoring question before in grade 10 or grade 11 or something? Okay. What was so special about factoring? The questions always look like this. I'm going to show you on the Microsoft Paint. Every factoring question you've ever seen, I guarantee it, it always looked like that. The teacher gave you this, something like this. Okay? And they said what? Factor. Or find the factored version. Okay? Or find some word that has the word factoring in it. What did you always have to do? You always ended up with this final answer. Look. How many people remember that? Yes, that's what factoring is. Factoring is taking something that has no brackets and creating what? Brackets. How many pairs of brackets are you creating? 2. A pair here, so something inside this, and something inside this one. Your factored form is going to look like this. This is called what? Factored form. This right here. So let's actually what? Write it down. So factored will look like this. Again, what do we start with? Same way we start every time. Not A, something. I want to emphasize that your first number can be what? Can be positive or negative. So go ahead, plus minus A. Hold on, let me write this so you can see the space. Let's go with purple, sure. Plus minus A. And then how many pairs of brackets? You have got to have 2. Okay, what goes in each one? Okay, the first thing that goes in each bracket is what? Is a single X. So you put X and you put X. Okay, and then you put what? You put a number here and you put a possibly different number here. And the numbers also could be what? Positive or negative. So go ahead, put positive, negative. Whoops, sorry. Put positive, negative. Positive, negative. Okay. What symbols did we use for the standard form? Like what letters? Come on, what did we use for the standard form? A, B, and C. What did we use for the vertex form? A. No, forget the X's. Forget the X's. What are the other layers? For the first one, you used A, B, and C. For the other one, you use what? A, H, and K. For this one, can I use A again? No, I can't. I've already what? Yeah, I can't say A here and then say A, B here. I've already used the A. Okay? Again, what is the pair they use here? I did not make the rules. Okay? The pairs they usually use are R and S. R and S. So you put R and S. Who would like to guess the rules again for this one? What was the rule always for A? Can be any number except for 0. Go. A can be any value. I'll squeeze. Except, sorry, yeah, except 0. Okay, how much freedom did I have with B and C from the first one? How much freedom did I have with B and C from the first form, from the standard form? They can be anything, including how much freedom do I have with the H and K from the second form? Same thing. How much freedom do you think I have with these R and S in this form? Great. Oh, my bad. I can't cross the slide. All right. R and S can be any values, any values, including 0. Including. All right. Time for examples. Oh, good. Thank you so much. Hamad, you give me example this time. Anything you want, any 3 numbers you want, as long as satisfy the conditions in red. -8. Hold on. Oops. -8. You said yes. Open bracket. X. Sure. So say again. Okay, hold on. What'd you say? 2/1. Hamad said 2/1. Technically, 2/1 is what? What's 2 divided by 1? 2. So in this case, you can just what? Say 2. If you really want to give it as a fraction, maybe you could say what? 1/2. Which one do you want to go with? 2? All right, 2. Yeah, easy choice. Okay, what's your second bracket content? X. X. Nice. X -2. Okay, everyone, let me show you. Listen up. I'll show you something very interesting we'll see when we sketch this one. So -8, x, was it +2 or -2 first? +2 and -2. All right. Everyone, let me just change this to be, I'm going to go from -5 to 5. I'm going to go from -7 to 20. Nope. To 30. Nope. 40. Yes. Okay. Open up or open down? Why? Look at the equation. What do you think always decides if it's open up or open down? The very last number, the second number, or the very first one? The very first one. What's up? Oh, you see? So what's my first number? It's negative. I don't really care if it's an 8, as long as it's a what? It's a what? Okay. Everyone, look at this. Where does it cut the x-axis? By the way, do you remember what we call the points at which it cuts or crosses or touches the x-axis from 2 days ago? That's what the quiz is on, actually. What do you call those points at which it cuts the x-axis? You can look at your notes if you want, from 2 days ago, Wednesday. Yes, Patrick. The x, the x-intercepts or the x-ints. What's another name for them? They have two names, x-intercepts or zeros. Why do you think they're called zeros? What's the y value here? 0. What's the y value here? That's why I call them the what? The zeros. It's where the function has a height of what? It's basically where it touches the ground. If we assume that the x-axis is the what? Is the ground. I always like to say that the x-axis is the ground. So this part of the function is above the what? Above the ground. And this part is what? Below the ground. Okay, question for you. What's this number? What's this number? Do you have them in the equation? Yes, you do. Is that a coincidence? Do you think that's a coincidence? No. How can we prove it's not coincidence? Let's come up with any other numbers you want. I want you to give me a different number here than +2, and here a different number than -2. Anything you want. Go. Seriously. Whatever you want. Whatever comes up. Okay. Again, remember, it could be positive and negative here. It could be positive and negative. So both of them could be positive. Both of them could be negative. This could be positive and this could be negative, or the other way. Doesn't matter. Remember, 100% freedom. So, okay, we already picked -8 here. I'm not saying you cannot pick -8 here, but let's just choose something else. -6. Everyone, look. -6. Okay, what do you want for this guy? You want -9? Okay, everyone, look. Oh, where did the parabola go? Do you think it's still there? So why is it not showing? What do I need to do? Zoom out. See, I'm only showing you from where to where. From what? From where? -2.5 to what? To 2. And from where? Roughly maybe -1 to what? I need to what? Zoom out. Where is the parabola? Everyone look. What do I still? Found it. Okay. Okay, everyone. Look at those values. What's the first value? Forget the zeros. The zeros are always going to be there. 6. What's the other value? Are those values up there? But there's a slight but important difference. Yes, here they are what? Positive. Here they are what? So if I tell you those two numbers, can you always know those two numbers? But what do you need to? You need to pay a small price, but an important price. What do you have to do with the sign? Flip. Is that a coincidence? Never. Hamza, give me another one. Give me any numbers you want here and make one of them positive and one of them negative. Again, we're going to keep this as -8. Sure. Anything you want. I can zoom in and zoom out as much as I can. So we have infinite display. Sure. 8 point. Do you want it negative or positive? Sure. Everyone, positive 8.5. Sorry. Yeah, 8 point. Okay. What's your second number? Yes. Let me just do this one. Huh. Negative what? 5/8, which we know is going to be a decimal, right? What was it? Do you remember what was the decimal? Yep, 0.625. So you're going to say what? Negative what? 0. Okay. Do you see where they are? No. Okay, everyone, pencils down. Look at the screen. I'm gonna. Well, let's guess this together. Okay, Hamza, what's your first number? What is it here? So we know on the axis it's gonna flip to a what? So you're saying my first cut is gonna be at x equals what? Okay. How about your second cut? Come on. What is it in here? 0.625 with a negative. What is it going to do when it flips to real grid? It's going to be a positive. So he's saying my second cut is at x equals what? Positive 0.625. Okay. Where is negative 8.5 on the x-axis? Is it on the right side or the left side? Left side. Close to the origin or far? Kind of far. So let's say it's going to be right here. How about the other cut? Where is the other cut? 0.625. So it's on which side? The left or the right one? The right one. But is it far away from the y-axis or close by? Yeah, look, it's not even one. Okay, question. Do you think this is going to be end up being open up or open down? And you have to tell me why. How many people say it's open down? Raise your hand. Hiba, why would you say it's open down? Because the what? What's negative? The what? The very first number, the one before all the brackets, is what? Negative. So, Hiba, is this correct? Is this open up or open down? Open up. So I have to what? I have to what? Flip it. All right. So I am proposing that the general shape of my quadratic is, or parabola is this. By the way, could it be like this? I don't know, right? But I know that it cuts where? Here and here, and it's open what? I don't know if it's wide or thin. I have no idea. High or low. I just know it kind of looks like this. All right. Everyone, let me freeze. So you can just see it pops out. So I'm going to change the grid size. I'm going to go -9, 1. Then I'm going to go curve. Okay, everyone ready? 3, 2, 1. Look. Is that similar to that? Yes. Okay, let's click the points and see. What's this point? What's this point going to be for sure? Yeah, because it's on the right side. That is the power of math. Understanding math enough with the help of Desmos that you can always predict without using what? Without using graphs or Desmos anymore, because you know that the system works 24/7, 100% of the time. Okay, so let's just finish this one. Where's my marker? It. Oh, okay. So we said, okay, minus what was it? Sorry, what was it? -8 x plus 8.5 and x minus, what was the original fraction you used? 5/8. Sure. Yeah. Can someone tell me what would make this a line? Oh, Hamad, you can. What would make this a line? What would destroy the curve? If you make which one of these three numbers a 0? The very first one. Everyone, check out what's going to happen. Listen up. Fatma, look. Check out what's going to happen here. If I make the a 0, it's going to be a line, but look where the line is going to be. Everyone, look. Just 5 seconds. Everyone, I'm going to make that -8 a what? Look what's going to happen to the curve. Just keep looking. Is it a line now? Where is the line exactly? On the what? On the x-axis perfectly. Right on the what? Right on the ground. Why? Because when you multiply 0 by anything, the whole thing just becomes what? 0. Not just the second part or the first part or a middle part. The whole thing becomes what? Which means what? The entire function just what? Collapses to the ground. Is it making sense? Y equals 0. Look, I don't even have to look at this line. Y equals 0. Same thing. just y equals 0, which means you're just walking on the ground. No up, no down, no curving, nothing. So let's write an example here. I'm going to write a generic example. I'm going to say 0 x minus 7 over 3 times x plus 1.7. Wrong. This is a what? This is a line. Done.